Hey everyone, today we are going to discuss about how to describe the data. So this is unit 2 in data science. So already we have discussed a lot in unit 1. So that is how to collect the data, how to process the data and how to process entire thing for doing data science process. So the entire data science process we have discussed in unit 1. So now we are going to see about how to describe the data in unit 2. So let's discuss about the topics. So this is a main topic in Unit 2, describing data with the tables and graphs. So these are the two ways to describe the data. The first thing is describing data with the tables. These are the mainly used in data science process. And second one is describing data with the graphs. So under describing data with the tables, we will see some of the main concepts that are frequency distribution for quantitative data, then guidelines, outliers. We have seen already about outliers in unit 1 itself. Here also we are going to discuss some of the concepts about outliers and relative frequency distribution, cumulative frequency distributions, and the frequency distributions for quantitative, that is nominal data, and interpreting distribution constructed data. These are the concepts we are going to discuss in this topic. So in graphs, these are the topics we will discuss later. They are graphs for quantitative data, typical shapes, a graph for qualitative, that is nominal data, and misleading graphs, doing it yourself. These are the topics we will see in future about describing data with graphs. First, we will see frequency distribution for quantitative data. Here, a frequency distribution is a collection of observations produced by sorting observations into classes and showing their frequency of occurrences in each class. Here, the only one main concept is the number of times the data is occurred in the given data set. That is the collection of data, the number of times a particular data is present in the collection. That is the occurrence mentioned here. This is the example I have taken for explaining you about frequency distribution. So in this example, the number of values is 53. So as our requirement, we can choose the number of values for example. So I have chosen here these 53 values as example to explain the frequency distribution. So first, in frequency distribution, there are two types: frequency distribution for grouped data and the frequency distribution for ungrouped data. First, we will see what is ungrouped data and how to do this by using the given example. So this is the example table 2.1 is explanation about frequency distribution for ungrouped data. For doing this, first we have to find the highest value in the given example. Here the 245 is the highest value and the lowest value, and also we have to find the lowest value. Here the lowest value is 133. So first we should start from the highest value 245. From 245 to 133, we can list out all the numbers from highest value to lowest value. After doing this, that is this method is called sorting. After doing this, we have to find the value in the given data set. That is, first value is 245. 245 is present in the given data set or not? Yes, it is present in the given data set. And then we need to check how many times the data is present in the given data set. Here the totally 245 is present only one time. So the occurrence of 245 is 1. So we can put here, that is the frequency. Frequency of 245 is 1. That is the number of occurrences. And next we have to find for 244. 244 is not present in the given example. So the frequency is 0 here. And 243 also not present in the given example. The frequency is 0. So 242 also 0. Likewise, we have to find the frequency for all the entire values from 245 to 133. So finally, we have to count all the frequency values. Here the total number of frequency values is 53 because the number of values in our example also 53. So the frequency of our example also 53. So in this way, we can find the frequency distribution for ungrouped data. What is and this is the example of how to find frequency distribution for group data. So first, we need to find the classes. It is totally depends upon our given example. Example means the number of how many values and what are the values for present in our example. So based on those our example, we can find the classes and the class intervals to find the frequency distribution for group data. So for finding frequency distribution for a group data, we should follow some of the rules or guidelines, whatever may be. So we should follow some of the rules when finding frequency distribution for group data. So there are 7 rules are there. In that 7 rule, first 3 rules is must. We should follow the first 3 rules. Remain 4 are optional. The first 3 rules are called essential rules. We should follow everywhere when we are finding frequency distribution. The last 4 rules are optional and can modified or ignored as circumstances warrant. When finding frequency distribution for a large set of data, we should consider the more than 10 classes in order to portray some of more fine-grained data patterns. When describing small batches of data, you might aim for fewer than 10 classes. It means, suppose our example dataset contains more number of data. So we can categorize the data into more than 10 classes. If suppose our dataset, our example dataset contains less number of values, we can categorize the data below 10 classes. So we should keep always in mind. So these are some of the basic rules we have to follow when we are finding frequency distribution for group data. So gap between the classes means when we are categorizing the data and dividing the classes, we have to follow some uh, gap intervals between the classes. The interval between the classes should be unique. Suppose the first class interval is 10, then we should follow the same for the remaining classes. The second class interval also should be 10 and the entire class interval should be same 10. Suppose if the class interval, first class interval is 1, then we can retain and maintain the same interval for all the classes. And these are the rules. These 3 are the essential rules we should follow when we are finding the frequency distribution for group data. First rule, each observation should be included in one and only one class. Each value, that is each data, should be mentioned only one class. It should not be repeated any of the classes. We should follow this clearly. Then second rule is list all the classes even though with a 0 frequencies. So this method we are following in ungrouped data also. Suppose if any one of the data is not present in the list also, we have included in that list. The same way here for in frequency distribution for group data, we should categorize the classes. If suppose any of the data is not present in the particular class means that is not a problem, but we should mention that class also. This is the second rule. And all the classes should have equal intervals. All the classes in one example or one analysis should be in equal interval. So these are the main rules, 3 rules we have to follow when we are finding the frequency distribution. So these are the some of the optional rules. These 4 are optional. The optional first rule is all classes should have both an upper boundary and lower boundary. This is optional because it's some of the classes or some of the examples we may consider for the lowest class and the upper class. The lowest class may have the lower boundary or upper boundary, and also the upper class interval, it might have the lower boundary or upper boundary. Either or value may present. It's not compulsory. It should be present both the upper value and lower value. So this is optional one. And select the class intervals from the convenient numbers such as 1, 2, 3 or 10 or 5 or any values. So it is entirely depends upon our example data set. Suppose our data set may contain the values between or below 100, means we can take the class interval as 5 or 10. Suppose if this data set contains the values more than 100 or more than 500 or more than 1000, means we can consider the class interval is 100 or 500. It is entirely depends upon given data set or chosen data set. Okay, but we can fix the class interval as 10. It is easy to access or easy to use and easy to find the frequency distributions. So always we can take 10 as a class interval. That is not a problem. And also it will be easy when taking the class interval is multiples of 10. It is not a problem. Suppose if the data set values are below 10, means that time also we can choose a class interval between 10 or 1. So this is optional one. And the lower boundary of each class interval should be multiples of the class interval. So here the concept is, see here the starting value, the lower boundary is 130 and the upper boundary is 140. The next 140 is lower boundary and 150 is upper boundary. Here this is not compulsory. It will be like this. So we can choose 130 is lower boundary and 139 is upper boundary. And the next 140 is lower boundary and 150 is upper boundary. And also the starting value is 131. That is the lower boundary will be 131 and the upper boundary will be 140. Either any one of the option is correct. So it is not compulsory one. So we can make it our convenient. Aim for total of approximately 10 class intervals. So these are the optional rules when we are doing frequency distribution for group data. So these are the references you can see and search here. So remaining concept we will see in next class. Thank you.